In the preceding lesson, we demonstrated pass by reference using the ref and out keywords, both in the definition of a method that was receiving things by reference and also in the calls to methods that were passing things by reference. Now, in this example, we're going to take a look at passing arrays once again to methods. And again, we'll talk about the differences between pass by value and pass by reference. And in this example, we'll be focused on the ref keyword. Remember that the only major difference between ref and out is that a ref parameter has to be initialized before you pass it into the method, whereas an out parameter, the assumption is that the method itself is going to give that parameter a value, so it does not need to be initialized before calling the method. So here we have an array reference test class that contains just a main method, and I'm going to run the program first just so that we have the output on the screen and I can refer back to it as we walk our way through the code. So here in main, the first thing we do is create an array named first array, and we initialize it with the values 1, 2, and 3. Then we create another variable, first array copy, and we assign it first array. Now this is not making a copy of the object that contains 1, 2, and 3. What we actually have here is both first array copy and first array pointing to the same array object in memory, and that array object contains the integers 1, 2, and 3. Now the next thing we're going to do is a test of passing first array by value into a method. And to show you that when you pass the array by value, that the reference itself does not get modified, we're going to first display the contents of the original array, and we're using a counter-controlled loop in this case, but we certainly could have also used a for each repetition statement. And then we're going to call our method first double, passing just the name of the array as an argument, and then we'll display the contents of that array once again. Now let's jump down to the definition of first double. Try that again. And in the first double method, you see that we receive the integer array, which we're calling array, and we don't have a ref keyword or an out keyword, so this is a pass by value. We're going to receive a copy of the reference to the array. Now in the preceding example, we demonstrated that when you have a copy of a reference to an array, you can use that reference to modify the array's contents. And we're going to do that here at lines 83 and 84 by multiplying each of the array element values by 2 and storing the results back into the array that the variable array refers to. Now, to demonstrate that the parameter was received by value, we also try to modify the parameter to aim it at a different integer array in memory that contains different arguments. Now, this will modify the parameter locally inside of method first double, but it will not modify the original array reference back in main. So what we should see when we get back to main and display the contents of the array that we just modified is the original values multiplied by 2. So if I go back up to main, and again, this is the method call that we were just talking about, we're going to display the contents of the array after the call. And if I stop there and look at the output, we can see that before we called first double, the values were 1, 2, and 3, and after we called it, they were 2, 4, and 6, but not 11, 12, and 13. Again, the array reference was passed by value. Any modifications to the reference do not affect the original array variable back in main. On the other hand, because the reference was received by a method and actually refers to an object that was created back in main, we can still modify the original object. So you can modify the array object, but you cannot modify the reference that points to the array object when you're using pass by value. Now the next thing we do in main is a little if-else test here to see if first array and first array copy still point to the same array object in memory. When you use a comparison operator with references, it's asking, do these things refer to the same object? And this is an equality operator, so we specifically want to know that first array and first array copy are the same object in memory. And as you'll see in the output here, the references do indeed still refer to the same array. Had we been able to modify the array reference in the first double method, then they would wind up referring to different array objects in memory, and that's the purpose of the second half of this program. So let's go ahead and take a look at the second part of main here. We once again create an array. This time we're calling it second array, and at line 48, second array copy. And again, this is not copying the array contents, it is copying the reference to the array. So both of these variables now refer to an array object containing 1, 2, and 3. We're going to now test passing second array by reference into a method. And before we do that, we're going to display the original contents. So if I stop there for a moment, we're now in this part of the program, and we've now displayed the original contents of second array, which is the values 1, 2, and 3. Now, here at line 61, you can see a difference in how we're calling this other method, second double. We're saying that the parameter is being passed by reference, so second array is a reference to an array, and we're passing the reference by reference. When you pass any variable by reference, you can modify that variable. And from the body of the second double method. And we'll look at that in just a moment. In fact, we'll look at that right now. So let's go to the definition. And here we can see what looks basically like the first double method. It's called second double. The key difference is this ref keyword here, indicating that we're receiving the parameter called array by reference. Now, once again, we're going to modify the contents of the array that we receive by multiplying each element by 2. But in this case, line 99 is now going to modify whatever array refers to. Array actually refers to the reference to the array back in main. And because I have a reference to the reference, I can modify the reference. I can aim it at a different array object. So when I return back to main now, the original variable that we passed into second double is aimed at the new integer array that contains the values 11, 12, and 13. So we'll go back up to main, and to demonstrate that, we're going to display the contents of second array, which was passed by reference into second double. And if I stop there for a moment, we can see that the values are 11, 12, and 13 rather than 2, 4, and 6. In fact, had I also output the values of second array copy, we would see that second array copy has the values 2, 4, and 6. And in fact, I'll modify the program in just a moment to do that. Now, to prove to you that these are no longer the same array object in memory, we once again do a little if-else statement to compare the reference second array to the reference second array copy. If these are equal, we would print out the references refer to the same array, and if they're not equal, we print out that they're referring to different arrays. And you can see right now, indeed, they are pointing to different arrays. And just to confirm that fact again, let's go ahead and display the contents of second array copy. So I'll just put a little for loop down at the bottom of main here, and we'll change this to second array copy. And when I go ahead and rerun the program, at the end we can see that the values in second array copy are 2, 4, and 6, which is a different array object from the one containing 11, 12, and 13. So this is actually one of the things that makes C# a little bit different from some of the other object-oriented programming languages like Java. In Java, you do not have the ability to pass a reference by reference. In C#, you can use the ref and out keywords to pass anything into a method by reference.